Today we're on page 7 of our chapter 6 notes, geometric sequences. In a geometric sequence, the ratio, think of quotient, the ratio of any term to the previous term is a constant, and this constant ratio is called a common ratio, denoted by lowercase r. Okay, lowercase r, the ratio, the common ratio, is equal to the second term divided by the first, which would be equal to the third divided by the second, which is the same as the fourth divided by the third, or the fifth divided by the fourth, etc. The nth term of a geometric sequence with first term a sub 1 and common ratio r is given by this formula. A sub n is equal to a1 times r to the n minus 1. You have to memorize this. Just like you know the formula for an arithmetic sequence, well, now this is the formula for a geometric sequence. Also, just keep in mind that the second term would equal the first term times r, the third would equal the second times r, and the fourth would equal the third times r. So let's just go back and write this. For a geometric sequence, a sub n, the nth term, is equal to a sub 1, the first term, times r raised to the n minus 1 power. Writing terms of sequences. Write the first 5 terms of the geometric sequence. The common ratio is 3, the first term is 2. So a sub n is going to equal a1, which is 2, times our common ratio of 3 raised to the n minus 1. So our second term would equal 2 times 3 to the 2 minus 1. And 2 minus 1 is 1. So this would be 2 times 3, which is 6. Our third term would equal 2 times 3 to the 3 minus 1. 3 minus 1 is 2. 2 times 3 to the second. That's 9. Times 2 is 18. Our fourth term, 2 times 3 raised to the 4 minus 1. 4 minus 1 is 3. 2 times 3 to the third. 3 to the third is 27. Make sure you're following your order of operations here. And 27 times 2 is 54. And the fifth term, we can simply take the 54 and times it by 3. We're following 2 times 3 raised to the 5 minus 1. That's 2 times 3 raised to the fourth. 3 to the fourth is 81. Times 2 is going to be 162. Next we have r is equal to 1/2. a1 is negative 20. So if our first term is negative 20 and our r value is 1/2, then our second term would be negative 20 times 1/2 to the first. Negative 20 times 1/2 is negative 10. Our third term would equal negative 20 times 1/2 squared. 1/2 squared is a quarter. A quarter of negative 20. Love these fractions. Is equal to negative 5. Our fourth term, negative 20, times 1/2 to the third. 1/2 to the third is 1/8. Negative 20 times 1/8. We can write as negative 28, or we can reduce to negative 5 over 2. dividing each by 4. And our fifth term will be negative 20 raised to the, times 1/2 raised to the 4th. 1/2 to the 4th is 1/16. So this would equal negative 20/16, or reducing it to negative 5/4. Write the first 5 terms. So I have space here. Let me just list this. Negative 20, negative 10, negative 5, negative 5/2, and negative 5/4. This would be the first 5 terms. And let me go back to number 1. We have 2, 6, 18, 54, and 162. Identifying sequences. Decide whether the sequence is arithmetic, geometric, or neither. If it's arithmetic, find the common difference. If it's geometric, find the common ratio. Okay, so to determine whether it's arithmetic, geometric, or neither, well, let's see. If it's arithmetic, it would have a common difference. Does this have a common difference? If I take negative 2, subtract 1, that is equal to negative 3. Is negative 5 subtract negative 2, negative 3? Yes. Negative 8 subtract negative 5, negative 3? Yes. Okay, so yes, this is arithmetic. Common difference is negative 3. Okay, so let's try 4. Is there a common difference? The difference between 28 and 7 is 21. Nope, no way is the difference between 112 and 28 the same. So it's definitely not arithmetic. Is it geometric? Is there a common ratio? 28 divided by 7 is 4. Is 112 divided by 28 4? Yes, it is. And 448 divided by 112 is also 4. So there's definitely a common ratio here. So this is geometric. And the common ratio R is 4. Number 5. I'll try, is there a common difference? The difference between negative 2 and negative 5, which is negative 7. Is the difference between 4 and negative 2 the same? No, it's not. How about, is there a geometric common ratio? Ratio between negative 2 and 5 is just that, negative 2/5. How about 4 and negative 2? No, that's negative 2. So there's no common ratio either. So this is neither. Next, number 6. With these fractions, is there a common difference? Unlikely. Let's try for a common ratio first. So in other words, is there a common ratio is 3/4 divided by negative 3, which is going to equal negative 1/4. Use the calculator if you need to, or in class tomorrow we'll use the calculator. And negative 3/16 divided by 3/4. Does that equal? If I multiply by 16 here, that is going to result in negative 1/4, or negative. There is a common ratio here. So this is geometric with a common ratio R value of -1/4. Next, writing a rule for the nth term of a geometric sequence, use the formula from the other page. So let's recall that formula. A sub n equals a sub 1 r to the n minus 1. So we need our first term and we need our r value, our common ratio. All right, so in number 7 here, 4, 12, 36, 108, 324. A sub 1 is definitely the 4. What's our r value? Common ratio of 12 divided by 4 is 3. 36 divided by 12 is 3, so 3 is our common ratio. A sub n equals a1 r to the n minus 1. So a sub n equals 4 times 3 to the n minus 1. This is our rule. Find a sub 8, or the 8th term. So a sub 8 is equal to 4 times 3 raised to the 8 minus 1. Use the calculator. It certainly wouldn't work this out by hand. 3 to the 7th times 4, 8,748. Number 8. First term is 1. Our r value, 6 divided by 1 is 6. A sub n equals a sub 1 r to the n minus 1. Make sure you're writing this out every time. That's going to help you to remember it. A sub n equals 1 times 6 to the n minus 1. This is our rule. Okay. So our 8th term here would be 1 times 6 raised to the 8 minus 1. 8 minus 1 is 7. 6 raised to the 7th power is equal to 279,936. Number 9. Our r value, -6 divided by 2 is -3. A sub n equals a sub 1 times r to the n minus 1. A sub 1 is 2. R value is -3. This is our rule. The 8th term is 2 times -3 raised to the 8 minus 1 is 7. -4,374. Number 10, you're certainly welcome to stop the video and finish up to number 12. R value, 2/9 divided by 1/3. I multiply by 9. All right, least common denominator of all the denominators. We get 2/3. So our R value is 2/3. A sub n equals a1 times r to the n minus 1. 1/3 times 2/3 to the n minus 1. This is our rule. We're looking for the 8th term. Substituting 8 in for n and definitely going to the calculator. (128 over 6,561). And here we have our r value, -1/3. Our first term is 3. So a sub n equals 3 times -1/3 raised to the n minus 1. This is our rule. Substitute 8 in for n. And again, go to the calculator. Right? Key is in exactly as it is there. It's going to be 3, and then parentheses, negative 1/3. Close your parentheses, and we're raising it to the 7th power. Negative 1 over 729. And number 12. A sub n equals a sub 1 r to the n minus 1, 8, r value is 1/2. This is our rule. And find the 8th term. Again, go to the calculator, that's 1/16 or 0.0625. If you add the terms of a geometric sequence, it is called a geometric series. The sum of the first n terms of a geometric series is given by this formula. The sum of the first n terms, S sub n, equals A1, the first term, times 1 minus r to the n, divided by 1 minus r. And you do not have to memorize this. It's on a reference sheet. We'll stop here. This concludes our video for today.